All right, so this is a follow-up to the 3.1 imaginary numbers notes where we're going to look at not an algebraic definition, but a graphical approach. Okay, so what we have here is we have two axes, and we're going to define these axes slightly differently. We're going to call this one the real axes, and this one the imaginary axes. Okay, so for example, if I have the number 2 plus 3i, the real part is 2. Okay, the real part is 2, and the imaginary part is 3i. So in order to plot this, we're going to plot the real number as the x coordinate. Okay, and then we're going to plot the imaginary coefficient as the y number. And so in order to plot this, 1, 2, 1, 2, 3. Okay, this is the point that represents 2 plus 3i. Okay, so then if we have the number negative 1 plus I, this would plot as, okay, let's see, what is the x and what is the y coordinate? It's going to be negative 1 for the real part and positive 1 for the imaginary part. So that's going to go negative 1, 1. And this would be the number negative 1, whoops, sorry, plus I. Okay, so that is a geometric definition of the imaginary numbers. So what we're going to do next is we're going to add a little bit of vocab with this. Okay. Absolute value. Okay. Absolute value of a complex number. You're like, oh, this is weird. Okay, absolute value is considered the distance from 0. Okay, so in order to find the distance from 0, it would be helpful if I put this on an XY plane. Okay, so let's go ahead and look at an example. So let's plot the point 2, plus 3i. Sure, let's go ahead and do this one. So this gives me the point 2 comma 3. Okay, remember, this is for the real part, and this is for the imaginary part. So 2, 1, 2, 3. Okay, so the distance from 0, fancy that. It appears as though this right here is the origin. That's 0. This is the distance I'm asking about. Like, okay, well, how do I do that? Well, if you were to envision a triangle here, a triangle, you would have this side is 2 and this side is 3. So I believe we call this the Pythagorean theorem. Okay, so can you find that third side? Yes, we can. All right, so let's find the third side. So A is 2, B, okay, 13 equals C squared. So C equals, I'm going to go positive root 13 because we are talking about a distance. Okay, so the absolute value of 2 plus 3i is the distance from 0, which is root 13. Okay, let's go ahead and see if we can't try one more of those. Okay. Find absolute value of negative 3 minus 4i. Okay, that's the absolute value of a complex number is the distance from 0. So, well, looks like we've got a there we go, much better. Okay. Okay, so I'm going to draw it. Okay, so 1, 2, 3, 1, 2, 3, 4. Okay, so here is my point. Notice that I've got the units labeled, okay, and I want to find the distance to the origin. Okay, so now I'm going to create my triangle. We're going to go here and here. And I'm going to label it with the correct units. Okay, 3. Let's try it again. 3 and 4. Okay, so let's find the remaining side. C equals positive 5, only the positive distance because absolute value is the positive distance from 0, or in this particular case, the origin. Now, we have one more type of example that we're going to do here, okay? And this is going to be the I clock, okay? And we're still going to do this geometrically. So let's put our, see if we can make this a better looking line. Let's make it black, and let's make it filled in, a little skinnier. Okay. All right, let's draw another line here. Okay. The I clock. Now keep in mind that this is the real axis and this is the imaginary axis. So I'm going to put this point right here, okay, which is going to be, the first point is 1 plus 0i. Right there. Boom. This is equal to 1. Okay, now I'm going to plot 0 plus 1i. That is right here. So this point is equal to I. All right, now I am going to plot the point -1 plus 0i. That is right here. This one is -1. Okay. And last but not least, I'm going to plot 0 plus -i. And that is right here. Okay, so my points on this axis here have been plotted using our geometric approach. Okay, so now what we're going to do is we're going to see if we can't maybe define another operation or one way to get from this first point here on the real axis to this point up here. Okay, now how do I get from here to here? Well, I could multiply by I. All right, so 1 times I equals I. Seems okay. Now, how do I get from here to here? Well, it looks like I can do I times I equals I squared. But we know that I squared is the real number, -1. Okay, so I'm going to do it one more time. How do I get from -1 to -I? Okay, so I take I squared times I. I'm multiplying by I, which is I cubed. But we can see that I cubed is -I. Let's do it one last time. I cubed times I is I to the 4th, which is +1. And if I keep going in this pattern, it's called a cyclical or a cycle pattern. Somebody called this a loop, or a repeating pattern. Okay, so let's see if we can't use this pattern to answer some of the other questions we've got here. So what would I to the 6th be equal to? Okay, so one way to use this pattern is to, I to the 6th. So we have to start at I to the 1st. 1, 2, 3, 4, 5, 6. I to the 6th is equal to -1. Okay, let's try I to the 15th. Okay, so you're like, okay, this is getting a little messy. Okay, let's try it. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I to the 15 is equal to -I. And I could keep going in this pattern. I to the, 33rd. Okay, and you're like, gosh, counting to 33 kind of sounds a little bit obnoxious, and it is. So let's see if we can't simplify this. This one is the 4. What if I just count by 4s? Okay, what's the closest multiple? 32. And then count from there. 32, 33. So this is equal to I. Now, if I look at 33 and I divide it into 4, that's 32 at the remainder of 1. The remainder will tell you the particular location you are looking for. Okay, see that? The remainder will tell you what you are looking for. Remainder 1. Remainder 1 goes right here. Okay, so if I say I to the 201st, you're like, ooh, I can't count to 201. Okay, 201 divided by 4 is, ooh, big number, remainder 1. Oh, that must be equal to I also.